Part 2. Here's a pre-test. See how you can do. Which of the following describes minerals? Liquid, organic, synthetic, definite composition. The luster of a mineral describes its what? Reflection of light, color, ability to resist being scratched, or density. The streak of metals is what compared with non-metals? Harder, softer, lighter, or darker? Pyrite, halite, galena all have what in common? Cubic crystals, metallic luster, react with hydrochloric acid, or a hardness of 2. What is a property of pyrite? Is it ductility, brittleness? Sorry about that. Brittleness, inability to conduct electricity or heat, or dull luster. 6. A mineral with one perfect cleavage is gold, galena, mica, or olivine. 7. A mineral that can be recognized easily by taste is feldspar, quartz, apatite, or halite. 8. What's the problem with using only color to identify a mineral? And down below, match each of these minerals with its use. Halite, talc, gypsum, diamond, feldspar, quartz, calcite, porcelain, glass, makeup, drill bits, wallboard and cast, seasoning food and upset stomach, medication, or cement, and list 5 ways you've used minerals in the last 24 hours, and no, vitamins don't count. This is a set of questions you should be able to answer. Okay, first, what is a mineral? Typically in a class, here's what I do. We take a piece of granite outside and we start hammering it up. No kidding. We put on the goggles, we wrap the granite in a piece of paper, and we hammer it. You're welcome to try this. I think it'd be kind of cool. And then you start separating out the different things in there. And you find out you've got these black flaky things. You've got this pink or white stuff with parallel streaks in it. And you've got this clear stuff that looks like glass. There are other things in there too. But what you have are 2 types of feldspar, a silicate, biotite mica, thin little flakes, and quartz, the glassy material. Granite is a rock and it's composed of minerals. We could do the same thing with a cake. Well, kind of, it would be hard. Pull out the nuts, pull out the, raisins or dates. I like dates. And we could break a cake apart into its constituents. Now, we couldn't do that with the eggs because they undergo a chemical change. Okay, what is a mineral? First, it has to be solid. What's that leave out? Well, gases and liquids. It has to be inorganic. That means it comes from things that have never been alive and are now no longer living. So you can't take a 2x4, a piece of pine, and call it a mineral. It has to occur naturally. It can't be human-made. Now, in the case of things like moissanite, a weird mineral, hardness 9.5, that was first discovered at Meteor Crater just west of Winslow. We have made them synthetically, but they do occur naturally, but very rarely. It's kind of weird, but moissanite, the mineral, is most commonly synthetic. It also occurs, in meteorites. It has to have a crystalline structure. Remember that M.C. Escher drawing earlier of the flying fish? It has to have a pattern that repeats itself. It can't just be a mess or what we call glass. And it has to have a definite chemical composition. You have to be able to assign a formula to it, like SiO2 for quartz. It's always SiO2. Oh, sure, there are impurities in there, but that's still the quartz. Let's take a look. Is this a mineral? You bet. It's a diamond. It's carbon. Carbon, carbon. Is this a mineral? Whoa, let's go back. No, it's not, because it's not solid. These are silicon chips for either computers or photovoltaic modules. Is it a mineral? Well, that didn't occur naturally. Those silicon and oxygen do occur naturally. This chip isn't natural. How about ice? Is it a mineral? Let's take a look. Is ice a solid? Yep. Is it inorganic? It's H2O. Yeah, not from living things in this case. Does it occur naturally? It does. Does it have a crystalline structure? Yes, it does. Does it have a definite chemical composition? Why, yes, it does. So ice can be considered a mineral. So guys, if you go to get engaged and this is too expensive, just get your sweetie one of these and then put it into a ring and keep her in a really cold place for the rest of your lives, and she will be very happy. How many minerals are there in the world? Well, there are about 4,000, and there are more being discovered all the time. Let's start looking at the classes of minerals. Silicates, are supposed to be over 90% of Earth's crust. I have that going backwards. Silicates are things that contain silicon and oxygen. Examples? Quartz. These are quartz crystals. Quartz forms the basis of glass. Drinking glasses, glass that you look out of, and the best glasses and binoculars and spy equipment, stuff like that. Although fluoride is used in that too. Feldspar. Listen very carefully. It rhymes with pink. Feldspar, pink. Often is pink or kind of a pinky white, and it contains potassium, aluminum, silicon, and oxygen, or sodium, aluminum, silicon, and oxygen. It is a silicate. Feldspar, pink. Can you hear it? Olivine, which is like an olive green, is this, also known as peridot or peridot, is a magnesium or iron silicate. It could be either one of these in this structure. It is beautiful. I'm surprised it isn't more prized. Here's kyanite. This is an aluminum silicate, SiO. Second mineral family, the second biggest one, carbonates. They contain carbon and oxygen. These include calcite. I just love calcite. Dolomite. The penny is there for size, in this case a Canadian penny. You know. And aragonite. Now this is strange. Calcite is CaCO3 and aragonite is CaCO3. This comes in a different form. Sulfides and sulfates. They're important because they usually combine with metals. Anything with sulfur. Pyrite, we call fool's gold. And even though they tell you you can't smell it, you can really smell the sulfur in here. If you ever find a piece of fool's gold, hold it up to your nose, and it smells a lot like a match or like fireworks, for anybody who goes around sniffing fireworks. Gypsum is calcium sulfate, and sulfur is really important in a lot of our chemical processes. Between these three families, the silicates, the carbonates, and the sulfates, we have just gone through most of the mineral families or classes on the crust of the Earth. Now, one more, halides, which are called natural salts. Anything with something from the left of the periodic table and the right of the periodic table. Fluoride, calcium fluoride. Salt, sodium chloride. Sylvite, potassium chloride. Sal ammoniac, which is ammonium chloride. And a lot of the things that are left behind by evaporites, including bromides, iodides, fluorides. These are all salts too. These will become important because as we start mining lithium salts out of Bolivia for our new batteries in the electric cars, that's important. The good thing is they're not too rare, and they're really easy to mine, and mining them doesn't destroy things a lot. In fact, right now, we mine salt in the western part of the Maricopa Valley, west of Phoenix. I think it's like 107th and Glendale. How do we mine it, and how do you not know about it? We inject water under the ground. By the way, notice the guy here. This is how big these crystals are. And these can take centuries to form. Can't believe he's standing on a crystal. Out on 107th and Glendale, you inject water under the ground. It dissolves the salt, and then you pump the water back up into ponds. You let the water evaporate, and the salt, sodium chloride, is left behind. And then we eat it or put it in our water softeners. Now, why are we calling these halides? The old Greek word, this is from Greek, for salt is alati, A-L-A-T-I, halide. Halides are salts. When I lived in Athens, I would go buy alati. Okay, there's piperi too. There is no pepper in there, it's clear. But that, being organic, is not a mineral. Now again, here are the major groups of minerals. You've had the feldspar group, which are all silicates. You have the amphibole group, which is really dark and it's silicates, and the quartz and mica group, which are all silicates. We don't care about that one. That one's ugly. So we have the silicates, carbonates, sulfides, and chlorides. Let's look at a few. There's also the native elements, which I love. These are pure elements. Now, here is graphite, which is pure carbon. Here's diamond, which is pure carbon. It's just that the atoms in diamonds are tightly tied together, whereas in graphite they aren't, so we stick it into pencils and we write or graph with it. Graphite means write-ite. Grapho, write. Here is copper. Here is gold, and I didn't stick, or is that silver? Hard to tell. I didn't stick one of those in here. There are gems. Now, gems are not always minerals, so don't be confused. Like tiger eye agate is amethyst with quartz on top of it. Chrysocolla is a mass of copper. Hematite, lapis lazuli doesn't really have a definite chemical formula, but it is pretty. Now, how do you identify what mineral you have? Well, it's kind of like this, but not really. You start looking at the characteristics. Was he tall? Was he short? What color clothes did he have on? The same thing with minerals. One of the things we can look at is color. There are some minerals that are really easy to identify by color. Azurite, which is a copper oxide, is always, well, azure. Malachite, the green stuff, is always green. Sulfur, in its pure form, well, one, it smells like sulfur, great smell, and it's always yellow. The lapis lazuli, which is not really a mineral, is always this color. Gold, well, it's gold, and olivine peridot is olive green. But not everything can be identified by color. Cinnabar can. This occurs in the mountains around Piestewa. If you go hiking along Trail 100, you'll find this. Here are three kinds of quartz. We have smoky quartz, rose quartz, and, well, quartz, kind of a milky quartz. One of the problems with color is if you get a little bit of impurities into a mineral, it can be a lot of different colors. Also, there are lots of different white minerals. With 4,000 minerals, I think there are at least a couple 300 that are white. So you can't just go out and say, I found a white mineral, it's quartz. No. These also are quartz. Here's citron, here's rose quartz, here's amethyst, which is mined out in Four Peaks and from Brazil. And this agate, just beautiful, with geode inside, all quartz. And here's what I was talking about. Just because it's white doesn't mean it's quartz. In this case, we don't even have quartz. It's albite, which is a silicate, calcite, which is carbonate, dolomite, which also is a carbonate, wollastonite, I think that's spelled, I wasn't sure there was an E in there, but I guess there is a sulfate, and gypsum, which again is a sulfate, a magnesium sulfate. And this is the fibrous kind. You can peel off these little threads. It's kind of cool. Here's fluorite, for example. It can be almost any color with impurities. So if color isn't reliable, what else can we use? Here's a hint. Streak. You rub the mineral across an unglazed porcelain plate, and if it's not too hard, it will leave a streak. Cinnabar, which is gray, kind of, leaves a brownish red streak. Pyrite, which is gold, leaves a gray streak. Most of the silicates this won't work with. We can look at luster, which is the shininess. There's metallic luster, and we know what metals shine like. And there's non-metallic luster. It could be glassy or pearly, which is shiny but not too shiny. It could be rosinous, or it could be dull, like earthy. And this one's almost like fibrous, although, what would you call it, pearly? We could also use something called hardness. Now, fingernail has a hardness of about 2.5, excuse my little screen thing on there. Copper penny, a little over 3. The knife blade, a little over 5. Glass, harder than a knife blade. I know this is weird, but when you get home, not at school, take out a knife from your kitchen drawer and rub it on the glass. If you don't slam it through the glass, believe it or not, it won't scratch the glass. A steel file, which has extra things in there to make it hard, will scratch the glass, so don't do that. We are going to pause right there. Be right back. There's got to be a better way to stop this thing.